Hi, my name is Callie Drake, and I'm a senior at Berkshire School. I'm very interested in sports medicine and desire to become a sports medicine orthopedic surgeon. With my interest in sports medicine and as an athlete myself, I wanted to research injuries obtained while playing sports for my advanced math science research project. I personally have watched many teammates and opponents suffer lower extremity injuries while playing, and they are usually people who wear cleats on turf. As a lacrosse player, I've seen numerous ACL tears. There has been a push to encourage female athletes to wear turf shoes on turf instead of cleats, since many girls who have torn their ACL were wearing cleats on turf. This led me to wonder how the type of cleat an athlete wears on a particular surface can affect their likelihood of obtaining a lower extremity injury. Moving beyond my personal experience, the National High School Sports-Related Injury Surveillance Study verifies the significant increase in the prevalence of lower extremity injuries in high school athletes. There were 1,397,490 nationally estimated high school sports-related injuries in 2017 to 2018, while over 50% of those injuries were to the lower extremities. I began to dive into researching what types of studies have previously been done to better understand the correlation between cleat type and surface type in causing lower extremity injuries. However, I discovered that the vast number of designs of cleats and turf shoes currently on the market prevents a robust longitudinal study from being performed, thus making it hard for athletes to draw meaningful conclusions from small-scale studies. The experiment I plan to perform is an attempt to better understand the correlation between cleat type and surface type to then infer about injury rates. The experiment was intended to measure the amount of torque generated by 4 different types of athletic shoes, 1 pair of lacrosse cleats, and 3 different types of lacrosse turf shoes. You can refer to Figure 2 to compare the different designs of the shoes. All 4 of these lacrosse cleats would be tested on 4 different surfaces: grass, turf with sand infill, turf with rubber infill, and turf with thermoplastic elastomer infill. 3 different weights would be added and tested to see the effects on the torque: 25, 35, and 45 pounds. Each cleat will be tested with each weight and on each surface 3 times, rotating both 30 degrees internally and externally. Figure 1 is a small-scale model of the testing apparatus which was created on Tinkercad and then 3D printed to give visual aid to allow the full-scale testing apparatus to be built. The full-scale testing apparatus was made of a wood frame that was 18 by 18 by 24 inches. There were 2 pieces of wood that formed a cross 10 inches up from the bottom of the frame and another wooden cross at the top of the frame that could be removed. Both of these crosses had a 2.2-inch hole in the middle where the pole was inserted. A free weight bar was cut to 26 inches and used as a pole to connect the shoe to the torque wrench while being able to change the amount of weight tested. This bar was attached to a wooden shoe insert that fit inside the various cleats and welded to a nut that was attached to the torque wrench. Unfortunately, I had planned to perform my trials once I returned from spring break and therefore did not obtain any results. I had hoped that the results of this experiment would allow high school athletes to make an educated decision about which type of athletic shoe they choose to wear to reduce their risk of lower extremity injuries. I hope to continue this type of research and to contribute to the knowledge of the impact of various cleat types and surface types on lower extremity injuries. Thank you for taking the time to listen to my presentation.